Hi friends, good morning everyone. So my name is Shravan. I work in power management integrated circuits domain. So as part of this, I'm starting a course here. I'm just learning in public. So in this course, the course name is Mixed Signal Mathematical Tools for Mixed Signal System Analysis and Design. So this course involves a lot of basic mathematical concepts, and then we will move to a more fundamental, more we will elaborate on more uh, some advanced mathematical tools which depend upon these basic math topics. So, for example, here in the part one, these are the basic mathematical concepts. For example, every engineer needs to know. So, complex numbers, sinusoids, sketching signals, Cramer's rule, partial fraction, expansion, and vector and matrices. So, basically, this course is more towards the electronic system design. So, and in fact all of these basic concepts are used in many of the advanced mathematical concepts. So after solving some problems here, and also we can also program in MATLAB to demonstrate some basic concepts here. And in the part 2 we'll go into the basic signals in nature. Okay, so and some examples in electronics specific to electronics, and also we'll also deal with some systems here, some electronic systems and its classifications here. And the electronic systems both process both continuous time signals and discrete time signals, and each have their analog and continuous time and discrete time have their own properties, characteristics, which we will deal with that about them here. So in the part 3 we will deal with as a human time domain, and in part 3 we'll deal with time domain analysis of continuous time systems. So as a human being, right, we would like to see any system operation in action, like with respect to time. So this time domain analysis gives us that intuitive picture. So basically, any system operation contains two aspects. One is the transient response, and the one is steady state response. And we'll see how to understand these, how to derive these responses. And we will also study an interesting tool called convolution convolution integral. So we'll understand these terms there. and and in part 4, we will deal with discrete time systems, time domain analysis of discrete time systems. In the continuous time, we usually deal with integral differential equations, and in discrete time systems, we call them as difference equations. So this part 4 is a foundation for sample data systems, for example ADC, DAC, and digital filters. Not only this, like many of the mixed signal systems like DC-DC converters are containing a lot of digital stuff within them. So it will be very helpful. In the part 5, we'll study with we will study continuous time system analysis using Laplace transform. Basically, we are moving now slowly into other domain. We analyze the systems in time domain, we get an intuitive picture, and we will see how this in time domain response, how this looks in the frequency domain. Okay, so basically we turn the system response to exponentials. We study a lot about exponential in this part 5. And we'll also I'll also introduce some electric circuit examples. In the part 6, we go through just similar to Laplace transform. Discrete time systems can also be analyzed using a tool called mathematical tool called jet transform. So here we deal with algebraic equations. So we'll go through it comprehensively. Okay. So in the part 7, yeah, this is a very interesting concept: Fourier analysis of continuous time systems. And we'll study side by side the Fourier analysis of continuous time systems and discrete time systems. So we will see how these both differ and which one has more advantage. Okay, so in the In the part 8 we will now transition, like basically systems which convert continuous time signals, okay, into discrete time signals using a process, using a technique called sampling. And this we will thoroughly study. We will express them, we'll study it quantitatively as well as qualitatively. And in the last part 9, we'll study about state space analysis. Until now, till part 8, we were only concerned about external input and external output. The system is kind of a black box for us, whereas in this state space analysis, we come from external description. Like now, we also study the internal description. We express internal description of a system in terms of state variables. So we'll go through this state space analysis. And the part 10, last and the best thing here is that it's kind of a bonus. We will study in detail the analysis and system modeling of DC-DC buck converter. It's a kind of a mixed signal systems, and this will be done using open source tool. Best I'll be introducing a very one of the best tool for all. It will be This tool can also be used by all startups or hobbyists or students, especially the semiconductor startups, especially the semiconductor startups, because of the financial with financial considerations. So this open source tool can be the best to begin with, to set the specifications for an application and just begin. And once the system specifications are set, you are set to design. So that reduces the cost and the time as well. So I hope you found this lecture interesting, and this is my first lecture and entry into YouTube. Please support me. Please watch it and subscribe, and also comment if you are whatever you agree or disagree. And I will come up with the next lecture soon. Thank you everyone.